Angular velocity describes how fast something is rotating. Angular velocity is designated with the Greek letter omega and expressed as a change in the angle of rotation over time. So we are talking about how fast the angle changes. This is expressed in radians per second. If we take our full circle ball, the radians covered is 2 pi. So its angular velocity would be 2 pi divided by t seconds. You might be noticing about now that before we calculated the orbital velocity as the circumference divided by time. We can compare that to our angular velocity. Algebra savvy someones might notice that we could multiply both sides by r and find that circumference divided by time is orbital velocity. So the angular velocity multiplied by the radius equals the orbital velocity. As you might expect, because it is traveling a further distance in the same time, an object further from the center of rotation would need to have a higher velocity than one closer to the center of rotation. We can show this mathematically. The rotation angle is equal to the arc length divided by the radius. And rearranging this gives us the arc length equal to the radius multiplied by the rotation angle. We also know that the linear velocity of an object is the arc length divided by the time. We can substitute radius times rotation angle for arc length in the velocity equation. Remember that rotation angle divided by time is an object's angular velocity, which very nicely fits into our new velocity equation, giving us the equation for linear velocity of an object moving in a circle. One thing to keep in mind is that velocity always includes direction. In the case of angular velocity, there are only two choices, clockwise or counterclockwise. If we increase the radius of our rotating object, the linear velocity of the object will also increase. Here's a pretty neat relationship that goes along with that. Consider the car in figure 6.5 that is moving at some velocity v to the right. The car is rotating with an angular velocity omega. The speed of the car is equal to the linear speed of a point on the rim of the tire. If you were to put larger tires on the car, you would move at a higher velocity.